This is interesting to me because I write C++ like it's C mostly. There's not a single C++ feature that I use except for stuff that was already present in C and operator overloading. I think that's about it. Not a single template. One I use. What about classes? All of the classes that I have in the game are structs. AKA they have a public constructor and I guess destructor. I don't think there's even a destructor and a struct, is there? Methods, I have functions. So for example, I have this function right here that takes in the pointer to an entity and gives me back their vector to rectangular collider. The origin of that rectangular collider, and then another function that gives me the actual rectangle. I solve everything by having a list of functions that I can call. Why not a method then? I don't know, I don't see a reason to do it. Like, it's like the reason why I'm not doing it is because I don't see an inherent advantage in having a method on the struct or having a function outside. And so another big reason why I don't use many C++ features is because for me personally, it is simpler to write the code and focus on solving the problem rather than figuring out which C++ feature is the best for the job. Because I purely work on transforming data from A to B rather than figuring out which construct in this case applies best. And also having to learn all of these different constructs. It takes time and I don't think this warrants the time invested. Now my point will only make more sense whenever my game is actually released and out in the public and has been tested more. I have a demo version right now of my game being played. Okay, so it's not like I have never released anything. It's just not per money. I don't earn money with this. It's a demo version, it's on Steam. So I have had people playtest my game and my program before, and it worked. It's just not 100% like ironed out. Let's see what he has to say.
Many people, when they see my style of coding, say that I write C code in the C++ language. And that seems weird.
Yeah, I get that too. Like, these guys are just haters, bro.
But it is intentional, and many people do that.
Yeah,
so today,
true.
I want to show you my style of coding that I have developed over the years while doing game dev in C++. Explain why it is like this, and I will also show you one small trick to add to your coding arsenal that will instantly make your code way more robust and maintainable. So let's go.
Okay, one trick.
So C++ has many features, but I don't use most of them. And the reason is that they are either very hard to use correctly, or they don't give me any benefit. So
there's like multiple rules, always. Yep. I hate that. There's so many rules and things.
So I want to convince you with an example first, and then I'll go over my coding style.
Okay.
So this is my custom implementation of a vector. So it is just like a normal C++ vector, but it has a trick to grow in O of 1. I have a video on that.
Okay.
And if you look at the implementation, we can see some functions here, like pushback, popback, and some equal operators. So it's okay if you don't understand everything. But right off the bat, notice that I need to manually call the destructor of the elements here.
You need to manually call the destructor of the elements here. Okay. Pop back.
Otherwise, they won't be destructed. So that can be a nasty bug if you forget to do that. But looking at the other things, do you see?
Okay, so he's made a vector. I don't really think you even need a vector in your game. I never needed one so far. I just waste space. In the grand scheme of things, if you have one too many textures in your game that you don't use, and it's a 4K by 4K texture, that is going to be more memory wasted than having an array where you only use 10% of the size of the array and you keep it packed in the beginning. Unless you have ginormous objects that need to grow, I never really saw the reason to use vectors. Other than it being easier to use. You just add and you don't worry about allocating memory at all. You also just crash if a player has a game state that you don't expect and grow beyond the size. Yes, you will have to log this and handle this in a way, of course. If you grow beyond the size, the game will crash, yes. But this is what, in my opinion, this is what playtests are for. So you could have the other argument that if you unexpectedly grow a vector, you're running into memory issues. Maybe even memory leaks. And so you could have the same thing happening in your fixed size arrays where you figure out, okay, the program crashes. It throws me an exception because my fixed size array is not big enough. Then you make it bigger and it should go away. Until someone else stumbles across another problem that makes you need to grow the vector as well. Where you have to grow the array again.
See any problem? Well, this equal operator was wrongly written. I wanted to reuse the operator from above, but using move here will actually make it recall itself, causing an infinite recursive function call. Whoops. And you can probably start to see the problem.
With simple procedural programming,
things are simple, and you can reason about your code. But the more complicated rules there are, like the fact that there is an assignment operator.
Oh, I see. So his point is that I didn't understand anything. Yeah, I didn't.
An assignment of temporary variables, like you can see here, that was called from this move here, adds very subtle bugs and problems that you can just very easily miss, even after looking at them for days. And you want to hear the worst part? This code compiles. And while you could catch the bug if you were lucky to call this function, that is only called in a situation like this. Oh wait, this seems to also call the copy constructor here, and that also has a problem that I didn't catch before.
I mean, what I get from this so far is that you should use the standard libraries vector instead of making your own vector, brother. Is that what you guys get? Like, do you guys get the idea like, oh, you should not use vector? Or do you more like, hey, guys, how about you just use the standard libraries vector? You know, that's okay, well, let's see.
Okay,
but he's cooking, I guess.
Okay, getting back. This could have caught my bug, but there might be other problems lurking. Like here. This line should actually have been like this, because in this way, the code will do less unnecessary
True. I don't understand anything, but true, yes.
constructions. And I managed to figure that out using some unit testing. And this is the problem. Unless you are a C++ guru, you can't tell that this C++ is 100% correct, and that there is no C++ quirk to break it. I hope you can believe me that while trying to construct this example, I just introduced this problem here to illustrate. And then I also found this problem with the copy constructor, and also the problem with this thing. And this is an old repo that I debugged and tested a few times over the years. And every time I look at it, I find a new problem. And trust me, I have been doing only C++ for like 10 years. I know C++.
Yeah, this guy's been making C++ stuff for a long time, bro. I'm 4 years in, by the way, guys. 4 years. 4 years. How does any of this relate to why you write C++ like C? I don't know. We'll see. Maybe he's cooking still, okay? He's still cooking, guys.
So this is why the standard implementation of a vector looks so weird. Because that's the correct way to write it.
Yeah, so he's, guys, you know, he added the salt right now, okay? It's starting to taste like something, okay?
I don't know about you, but I don't want to write code like that. So my strong recommendation is to write simple C++ code in your everyday.
But you could use the std vector. I don't like using std vector, but you could use the std vector instead. And reserve memory, yes, std reserve, you know, vector reserve behaves like an array. True, yeah.
Coding and do weird stuff like this only if there's no alternative. Still, don't agree with me?
No.
What do you think is harder, making a Minecraft clone or writing a C++ vector? Well, I'll tell you that I can make a
Actually, I think it's the vector, to be honest. Not because of the sheer amount of code that you have to write, but because the vector is so difficult to write because there's so many nuances. Look at the standard library. I don't want to write code like this. Yes, that's why it's in the standard library, so you don't have to. Yeah, true.
Minecraft clone. But my vector, that I even built unit tests for, still has a problem that I just found now. You didn't expect that, did you? You saw that I was done, but no. Using memcopy here is wrong and can sometimes, and I underline sometimes, break your program.
Who in chat said earlier that memcopy is wrong? Who said that? Who of you guys in chat said that? Who was it? Me? Me? Okay, those who are lying get banned, by the way. Cranky. Memcopy was also... Okay, Cranky said it. Cakez fart, Galaxy Media. See you in 5 minutes. You're lying. You're trying to reap the fruits of someone else's labor and smartness. Okay. You're lying. There you go. Idiots. Okay, collector of stuff is gone too. For 10 minutes. Just give him a 10-minute break. You're wrong. You're wrong. We all did. Kind of pathetic that you're the only one who didn't see it. Okay, pre-watched equals smart. Oh, actually, I think he pre-watched it, yeah. I don't understand why you're banning.
So I believe that it is great that we have std vector. And I love it. And I use it every time, but I'm not implementing something like that every day. So I sometimes like to think of C++ as C with vectors. With this in mind, let's look at my coding style, and also the trick that I promised. I like approach-based design. This means write the code first, then make abstractions. Like, how can you make abstractions if you don't...
Yeah, write the code first. He means, let's say you have a particular problem, like for example, colliding projectiles with enemy units. You write the code that works, and then you figure out, oh, okay, so I use this code here, and I use this code here. These two code paths work together. Maybe I should create a function. Maybe I should abstract away. True, yeah. That's what I do too. It works very well.
Know how your code will look. And then, about coding itself. In general, I write most of the code procedural. If a function becomes big, like the main function, I split it in regions sometimes, then smaller functions.
I do this too. These are called scopes, and you can name the scopes, and then you can use folding, and you essentially have functions. You know, this is a function, get player positions and stuff. Now, is it a perfect name? No, but you would have the same issue with a function name. Yes, and so this right here will most likely never be called in a different position other than in this particular position. So creating a function now makes it open to be called by anyone. And this could introduce bugs because maybe the function does something else that you don't expect. And then maybe you have to go and redo the function and only extract this one part out. And now you have this one function calling the other function. And you know, the other function just calling this part of the function. Yeah.
Also, you can see that I'm not a fan of having many very small functions. I think that makes the program harder to read actually.
Yeah, I think so too. I think I like reading from top to bottom like a book. It's really nice.
Into functions or classes when it makes sense. I also use lambdas quite often to make some temporary functions. I don't like...
Yeah, me too. Like I create locally scoped functions when I know that I only need this function in this local scope, but I need it in 2 or 3 different places. Yeah, and I don't want to write the same code, like copy paste it. Yeah.
Functional programming, but I do like not saving too much state. I instead recalculate it when I need to, so from that perspective.
So like, yeah, you can use public and private to create access to your functions. I agree, that's another feature. I treat access as scope levels. So my access to public and private is defined by the level of scope that I use. If it's inside the function, it is local. If it's outside the function, it is global. And if it's inside a function, inside an if statement, then it's only inside the if statement of the function. And so the deeper I go, the further away it is hidden from the outside. That's how I see it.
I write my code a little function. On this topic, I don't use events or callbacks. I try to, again, instead ask every time if something should happen rather than wait for an event trigger. If I'm inside a boss fight, for example...
I'm still debating on this one, whether that's a good idea or not, because I do that too. I always ask. I don't do an event too. I have learned, or I have tried events in the past, and the code for those was just really complicated. Now, you can do events by having, you know, function pointers, you know, stuff like that. This does work. And then I think it's called STD option. No, not option. It's STD procedures or something. I don't remember. But there's an STD version for function pointers.
I will check if the boss is live, drops to 0, instead of sending a kill boss event when it dies. I know that it might not seem like much, but things like this compound and can add weird bugs. For example, when I press Ctrl X on a folder, it will cut it, and it will make it look faded to signal that. But if I change the name of that folder, it will still remain faded.
Okay.
But I can't actually paste it anymore, because the name has changed. Now Microsoft did it like this, probably to save battery. But you can see how a bug was introduced. But for...
I see. So it's trying to paste the file using an event, and it stores the event or the data as a different file name. Interesting.
It's much simpler to just check every frame if the current cutted file is the current one, and if so,
change its appearance.
I also do some data-oriented design. So, for example, I like creating systems for contained things, and then pass them around as references. This makes it simple for me to see what system uses what. And you can do cool stuff by passing data around like this.
So when he says system, he means like data for input, data for the game, data for rendering, data for audio, and then all of these systems, just bundled data that are containing the information for audio, the information for the game. And then you pass the game state around, and people can change the game state or not.
Like, this is how I implemented hotcode reloading in my game engine. Check this.
Yeah, that's what I did as well. Hotcode reloading works because you're pasting. No, because you're not pasting. Because you're passing data around, and then everyone just reads the data, and you can keep the data in your main game and reload your code and just pass the data from your main game.
Video if you want to know how. I also prefer to write the code down, rather than have fancy abstraction systems where I can submit work. It is cool to have something like this, but you have to keep in mind that this makes them harder to debug if they interact, because I think that if you simply write the code, you can more easily see the code, read it, and step to it. For a similar reason, I don't throw exceptions. Using a procedural coding style, you can easily see and read what happens. But if you throw an exception, that's like having a goto, but a goto that jumps out of multiple functions. And not only that.
Oh, okay, but doesn't it show you the line where the exception happened? Doesn't it show you where the error happened? Not in C++? Really? No stack trace either? No stack trace? Oh, okay, that sucks. So this is what I use. It's assertions, not exceptions. That works very well. This stuff right here, for example. This helps. And then I have the stack trace available.
But potentially, it can be thrown from many places. So depending on the case, I return error codes, or my favorite trick, but I will leave that for last. Now,
assertions. 100%. Assertions. This is gonna be it.
to manage memory, I don't like classes to allocate.
They get optimized away in release. I decide what happens to them in release. I will probably log the error for now in the beginning, but I will make it so that the game won't crash.
Memory on creation, and making use of destructors myself. If needed, my structs have a create and destroy methods. You might think it's easy to have leaks, but I already made a video about that, so you can look there. The advantage is that if I have a class that has some resources like a texture, I can easily pass it around systems and delete it at the end. Now, I also don't use...
But you can forget to delete it, bro. But yeah, he's basically saying that in his memory video that you should have as minimal new and deletes as possible in your game.
polymorphism. But
so essentially maybe have one big allocation in the start and then you write your own memory allocator where you allocate or create your own resources in.
The reason is that I don't personally get benefits from it. And that is the case with many C++ features. So just because a feature is there, that doesn't mean you should use it. You should use it if the benefits outweigh the cost. And this applies to many things, so next time you want to do something a certain way, because that is what you see people do online, ask yourself if that will
See, this is what I do all the time. I ask myself, okay, if I can use a C array, okay, let's just make a very simple example, to hold data, why would I use an std array? It has a couple more functions than a C array, so that could be a reason too. And it is generic. That's also a good point to use it. So one could argue that, okay, using the C array is way more tedious than using my own array. Than using the standard library array. So I will probably want to use an std array. And then, you know, you could ask yourself the same question with vector. Do I want to use a vector or not? Would have been cool if he gave an actual example. Array size is tracked and passed with it, so it doesn't have to be passed separately. Yeah, so you just pass the array instead of the pointer to the data and the size, yes. I've been using C arrays for the longest time, and it was, I have to say, it was kinda annoying to always have to pass both parameters.
actually benefit you in any way, or it is just extra unnecessary complexity. And now, one of my best tips that I can give you, and that will improve your code base by a lot.
Assertions.
So imagine you have this function, and it is important the programmer will either supply no parameters here, or both of them. You could add a comment, but it's easy to not see it. Or even way worse, modify how the function works, but forget to remove this comment. Introducing asserts. Asserts are a special type of errors that are meant for the programmer to check its code.
I have those too.
They are meant to display an error message to the programmer.
So I have better assertions than he has, I think. My assertions debug break, and then I can debug the program the moment I hit this. And then I can decide what I do on release. Right now, I always do this, even on release, but I could have like a if defined release, if defined debug. Assertions are really good.
Tell him that he wrote his code wrong. So you can include the assert and use the standard assert from C++. If the expression inside it is 0, it will throw this message, and it will even allow you to debug if you are in debug mode. But
that's
keep
cool
in
too,
mind
yeah.
that this assert will not run in release mode, and it also won't even run the code inside it, so be careful. So if you want a release assert,
I think release assert, like this is how I do assert. It's called if not X, and then it does a debug break. In Win32, it's called debug break. On Linux, it's called built-in debug trap. This has worked for us. And on Apple, I think it's called built-in trap. And then you can decide whether you want to use this in release or not. This is how simple how you can make your own assert, by the way.
you can implement your own assertion function, like this. And there is also static assert. This is an assertion that happens at compile time. So for example, I have this class.
Yeah, I have that too. Static assert is really good. I have a bunch of damages, physical, fire, cold, lightning, and poison damage. And then I have colors associated with these damages. 2 arrays. I want them both to be the same size. So I'm using a static assert. I could program this in a different way, but yeah, I've been using this. It's very cool. This will give you an error when compiling then. And you can jump to this right away. And you can never make your game run unless you fix this assertion.
This is an assertion that happens at compile time. So for example, I have this class and I did some bit manipulation magic on it. And it will break if I change its size. So I can just add a static assert here. The code won't compile if I change the size of this struct, letting me know that I also need to update the code here. So whenever you expect your program to behave in a certain way, or a variable to have a certain value, you can add an assert there. And if it is triggered, that means that you have a bug. And because you added the assert,
Also
you got
compiler
lucky and
specific,
managed
not
to find
OS
it early.
specific.
And if you found this assert thing interesting, subscribe because the next video is also on that topic. So think about who else codes like you, and send him this video to also help him, and check out how I manage memory. See you!
See ya. See ya. Yeah, he's been making some good videos. I didn't know that he's been making C++ games or been programming in C++ for such a long time. You can see that he's learned a lot over the years. While this is also very generalistic, and you know, his cooking part with the STD vector, I think it would be cool. Like, in my opinion, this is more advertisement to use the STD vector than rather to make your own STD vector. Not really a reason to not use vectors at all. So, but his point, I guess, is that it's difficult to read. And I agree. However, you could also argue that the more you use the standard library, the easier it is for you to use it. And one of the biggest examples that I always see is Grinding Gear Games. They have been writing a very efficient, in my opinion, game in C++. And they heavily rely on modern C++. If you want to be an engine programmer for them, then you need to know modern C++.